Good day friends, today we are going to discuss about the boiler feed water treatment. In this video we will have the discussion on why it is necessary and what are the various tests which is being conducted on the boiler water, what are the procedures of it and the effects, that means the result after the test and actions required to be taken after the result. So all these things we are going to discuss in this video. This is the primary goal of a boiler water treatment. These are the things which is required, and due to this we are going to treat the boiler. Or if you have the question why it is necessary to treat the boiler water, or what is the benefit of boiler water treatment, so all these questions are answered over here. You can see this one. This is something which is to maintain clean scale free water side, that is basically your heat transfer surfaces in the steam generating and cooling water system. So we have this clean and scale free water side. So why it is necessary? Because otherwise it is going to impair the heat transfer, and finally it is going to increase the fuel consumption which is required for the generation of steam. So if you have the clean and scale free surface for heat transfer, it is going to raise the steam with less time period and the less heat required. Okay, next, to prevent the metal loss due to corrosion. So this water is alkaline, we are maintaining the boiler water alkaline, so this is also going to have a coating, internal coating, and prevent the corrosion. To ensure efficient production of steam in the boiler system. Okay, so if all these problems which we have just discussed is not there, then of course the efficiency in the steam production will be there, and prevents the priming, foaming and carryover and the contaminations. Okay, so next, to prevent the formation of deposits in the steam and condensate system. Of course, if the boiler water is maintained, the contaminants are less, or time to time the actions taken, that is your blow down and all, so you will have the floating contaminants less, so less deposits, less scale depositions into the steam and condensate system, and they will be healthy. To minimize the heat loss from the system due to excessive blow down of boilers. This is also one of the problem. Not only the heat loss, your chemical properties or the additives which you have added earlier, and this will be gone with the blow down. Blow down means basically we are you can say the removing water from the boiler, because the condition of boiler water is not as per the desired result specifications. Okay, to keep all power generating and auxiliary equipments and associated water and steam system at their most efficient level. Okay, and therefore the minimize the costs. Okay, so this is something which is the reasons, or these are the reasons based on which we are required to do the boiler water treatment. Now we are going to see some additional benefits of boiler water treatment. As we have seen earlier regarding the original benefits which we are getting from the boiler water treatment, but as you can see over here, the boiler water tests which we carry out will actually assess the condition of boiler water. This is the normal thing it looks like, but not normal. Okay, why? Because this gives you the real picture of the boiler water. And mind you that if it is a medium pressure boiler, that is approximately in the range of 20-25 bar, 16 to 25, so in that case every day the testing is being required, and the boiler water conditions are changing as per the requirement. Okay, so that is very necessary. If you are in dry fleet, then you may be doing the testing on weekly basis, but on tankers and all you have to do on daily basis. So you have to know actual condition of the boiler water, because based on that only you will be able to correct it, or the corrective action can be taken, either required to put the more additives or the chemicals or blow down, whatever the actions you can take only if you do the test. The absence of adequate external and internal treatment can lead to the operational upsets and total boiler failure. So this is the end result. which is said that if you are not doing this, then it can finally lead to the boiler failure. Next, based on the boiler water test results, boiler water chemicals are being added time to time. Not only the addition of chemical, you have the, so you can see this, the boiler water test. These are the most prominent tests, or you can say the test which is being carried out in the boiler water. One is your alkalinity test, phenolphthalein alkalinity. This is called P alkalinity. Total alkalinity. This is also called total alkalinity and 2 into P mostly. Chloride test, condensate pH test. Next is your emergene test, or it is basically the test of hydrogen. Excess phosphate test. Okay, conductivity test. This gives you the TDS, total dissolved solids. Okay, and then you have hardness test. Okay, so these are the important tests which is to be carried out in the boiler water. Let's say some discussion on the alkalinity test. This is to ensure that the boiler water prevents corrosion by neutralization of the acidic gases. What happened? We have to keep the boiler water alkaline. Why? Because it is going to make an internal coating inside the pipelines, the steam pipelines or the condensate pipelines, and this is going to prevent the corrosion part of it. Okay, so here the test is your P alkalinity test. This test is carried out to prevent the acidic corrosion. P stands for phenolphthalein alkalinity. Phenolphthalein indicator is being used, so phenolphthalein alkalinity. To test for presence of all the hydroxides, 1/2 of the carbonate and 1/3 of the phosphate present in the water sample. This is the basic thing. Basically, you are going to test the alkalinity of the water. Total alkalinity test, to determine the amount of hydroxide and all carbonates and 2/3 of phosphates. This is the main reason why we are doing the total alkalinity. Hydroxides and carbonates can coexist together in a solution, but hydroxides and bicarbonates cannot coexist, and this is something which is going to be the basic testing of the total. When we do the alkalinity test, what is the main purpose of the test? This is to measure the acidity or alkalinity of the water. This will tells you water is alkaline or water is acidic. Okay, and if it is, the test results are high, partial blow down and add sodium sulphate. So this is the chemical which is being added. What is the name of chemical? Sodium sulphate. Okay, next is low. If it is low, add NaOH to get the desired result. Okay, sodium hydroxide. Okay, so this is the action which is required. See that this is your just a pictorial representation of total alkalinity test. You have the procedure which is written over there. P alkalinity, add 100 ml of boiler water plus 10 drops of phenolphthalein. This is the indicator. If hydroxide or carbonates are there, then it will turn pink, and then add N/50 H2SO4. If pink color vanishes, then it means the hydroxide and carbonates both are present. Calculation, the N/50 H2SO4 into 10 ppm of calcium carbonate. Okay, so this is the P alkalinity test procedure. For T alkalinity, to the sample of P alkalinity add 10 ml the methyl orange. This is going to give you the orange color. If no yellow color appears, then no bicarbonates are being present. If by this yellow color appears, then add N50 H2SO4 till the color vanishes. Calculation is ml of N/50 H2SO4 multiply 10 is give you the ppm of calcium carbonate. So that is the end result. Here we are going to see chloride test and condensate pH test. Okay, so what is the chloride test? To know the amount of salt deposition, or you can say salt content in the boiler water, and to minimize the chloride level and to adjust the blow down. Because if you have higher chloride levels, we have to do blow down, but unfortunately when we blow down, the other chemicals which are already in good condition, that will also go. Okay, so we will lose lots of chemicals when we do the blow down. So we have to maintain, we have to test the boiler water in a good frequency or required frequency, so that we will come to know the condition of boiler water, and we will do the action or take the action accordingly. Condensate pH, to control the condensate pH value within a limit. Okay, so next, to minimize the corrosion in the steam and condensate. So when we talk about the condensate pH, so again it is pH means what? This is something which is going to tells you the acidic or alkaline, and this is going to affect on the steam and condensate. What is this chloride? Suppose, what is the purpose of test? To test the presence of chloride compounds. If it is high and increase, trace the source of leak, that means the seawater leakages, and to rectify, blow down completely and take the fresh feed. Once this is the thing, that means all chemical reserve is gone, and you have to again add from the initials. Okay, steady but high can be reduced by phosphate treatment and partial blowdown. Blowdown's frequency should be increased and testing should be done for the chlorides, and the phosphate treatment is done. Low, good, no action required. Okay, this is for the, you can see that this is your pictorial representation. Potassium chromate indicator is being added over here. P alkalinity sample plus 2 ml of H2SO4, then add 20 ml of potassium chromate indicators, and then add N by 35.5 AgNO3, that is your silver nitrate, until the brown color appears. So this is something which is your test. Emerging test is your hydrogen, also it is being called, to test for the dissolved oxygen content. This is basically the test of dissolved oxygen content, because oxygen content will be there, dissolved oxygen, it is going to cause the corrosion part of it. To know reserve hydrogen N2H4 ppm and to prevent the corrosion and aerations. Okay, so this is going to prevent the corrosion part of it and the aeration part of it. To minimize the oxygen pitting, what is the effect of the emerging or hydrogen or the dissolved oxygen? This is going to minimize the oxygen pitting and corrosion in the boiler lines, steam lines and condensate system. So all three systems which is associated with the steam generation and distribution, that is your boiler, steam and condensate pipelines, these are being protected if you have the good emerging content in your boiler. You can see this purpose of the test to test the hydrogen reserve. How much is the hydrogen reserve in the boiler water? Trace the source of leak and rectify it if anything is there. Blow down completely and take the fresh feed. Okay, how this one hydrogen, this is to check the reserve of hydrogen to combat the dissolved oxygen which we have discussed and which would otherwise oxidize and the metals of the boiler, and the corrosion will occur. This is your comparator type of the hydrogen kit, test kit. The sample has to be taken, 250 ml of the boiler water cooler, the sample has to be taken, and out of that 15 ml you have to take, and N2HCl and 2 nozzle cylinders are being required. First cylinder add 25 ml of sample and then add 4 dimethyl methyl amino benzaldehyde. Okay, this is the chemical. And then second cylinder add 35 ml of water and add this one and then match the sample. Basically the emerging reagent is there, and you have to put the reagent into this, and then you have to shake it, keep it for some time, shake it and keep it for some time, and then you have to put, see, this is the comparator system and this is the hole through which you can put inside, and you have to compare between these two and match the color and these two. So basically which one is the more closest one, matching one, that much is the ppm of the hydrogen. Okay, so we have to do that. Okay, dissolve oxygen sulfate reserve, this is to basically test the oxygen and chemical content of it. If it is low and persisting, check the source of air leakage and find out and rectify it. Low but steady, increase the dosage of sodium sulfate. High, then no action required. High, that means it is basically on your required test. Conductivity test is also very important. This measures the total amount of the dissolved solids or the solids which are present into the boiler water, which can create a effect on the boiler water conditions. This including the treatment of the chemicals. Excess density leads for the priming and deposits. So once the deposit scale formations, more fuel required, local overheating, and finally the failure of the tubes. All this is the thing which is there. Okay, to remove the dissolved and suspended solid by blowing down. If it is high, we have to blow down the solids. This is to indicate the density of boiler water, the quality of the total dissolved solids per unit volume or mass of the water, that is the indication. Density of the boiler water should be maintained low, because high density boiler water results in the precipitation and scale formation. So we have to maintain the total dissolved solid content low. Why? Because the density will be high, then it is going to precipitate and it is going to have the scale formation in the boiler. Okay, so if it is high, partial blow down and take the fresh feed. If it is low, good, no action required. That is the main part of it. Here you can see cool boiler water till room temperature. This is the test procedure. Add phenolphthalein and H2SO4 till the pink color disappears, and place conductivity meter with the temperature of the water set. Conductivity meter reading is being noted. So generally 500, 600, or less than that is okay. So TDS is equal to conductivity rating into 0.7. This is as per the meters which is. In this one we are going to see about the hardness test. Hardness test. Why this hardness test is being conducted, or what are the purpose of it? Hardness test is done to check for the salts which causes the hardness or scales. As we know that if we have the scale deposits, then in that case the heating surface will be deposited with the scales, and it will take more time to generate the steam, more fuel will be consumed, and this will go and affect the commercial aspect, and it cause the local overheating also, due to which the pipes and things can be damaged. So what is the remedy? Remedy is chemicals are added to keep this under control. Hardness test of boiler water are not necessary when the phosphate is above the lower limit of the control range. This is the note which is being given. Okay. You can see over here feed water hardness. What is the purpose? As we have seen, that to test the presence of the carbonate components, because these are the causes of hardness. Okay, if the test result is showing high, add the phosphates. If it is low, good, no action is being required. Test. Now we are going to see about phosphates. So this is basically, as we have seen, it is going to control the scale formation inside the boiler due to the hardness. If the phosphate will be present, so this means the no hardness salt is there. Okay, a reserve of phosphate should be maintained in the boiler water, ready to neutralize any hardness salt which may enter into the boiler and cause the scale depositions. Okay, for this we can have the excess phosphate test. You can see the comparator again, like hydrogen we have this comparator. So what is the procedure? 25 ml filtered sample of the boiler water plus 25 ml of vanadium reagent, or you can say phosphate reagent, is being mixed with. Leave it for the 3 minutes and compared with the color one. Whatever the sample you have to, suppose you put the sample over here and compare with these two, which one is the nearest? Suppose the nearest color matching is 30, so the ppm is 30. Okay, so this is something which is your excess phosphate test. Okay, in this pictorial representation, the test of the phosphate is basically we are doing, and we are doing it for finding out the phosphate reserve. So if it is low, then we have to add the phosphate as required, and if it is high, no actions are required. Important to maintain the phosphate level to approximately 10 ppm so that the scale depositions will be minimized. Something which is the summary: to prevent the scale, sodium phosphates; to give alkalinity, sodium hydroxide and sodium carbonate; to condition the sludge, polycarbonated or starch or sodium aluminates are being used; to remove the traces of oxygen, the sodium sulphate or the hydrogen is being used; to reduce the risk of caustic embrittlement, sodium sulphite or sodium nitrate is being used; to reduce the risk of carryover or foam, anti-foaming agents are being used; to neutralize CO2, neutralizing amines; and to protect the steam and condensate line, the filming amines are being used. These are the chemicals which is being used, and here in this column we can see the boiler and what is the pressure range. So almost you can see the high pressure boiler and medium pressure boilers are being utilized, but we are taking safe side. We are on board ship, we have all these things which is utilized, okay, in your low pressure boiler also. Chemicals used for the boiler water treatment. What are the chemicals? As we have seen earlier in the chart, here you have the sodium hydroxide also. What is the main purpose? The common name of this is caustic soda. It is an alkali which reacts with the harmful acidic part of it, and basically it makes the water alkaline and make it anti-corrosive. These chlorides, neutralizing them and converting them into the harmless hydroxides which precipitates, and the sodium chloride which remains in the solution. Basically sodium hydroxide is going to make the thing alkaline. Okay, sodium carbonate, this has a common name of soda ash, and it has an alkaline substance and react with any non-alkaline hardness salts, either precipitating them or converting them into the corresponding sodium salts which will remain in the solution. Any excess sodium carbonate also remain in the solution, providing the alkalinity required to reduce the corrosion. So basically this also is going to contribute towards the corrosion protection part of it. Okay. See the sodium phosphate. Here also we are going to see that phosphate react with the harmful scale forming sulfates and precipitating them as the corresponding phosphates. Okay, the usual form of the sodium phosphate used at sea are the follows. Okay, what are the forms which is used at sea? Is your sodium metaphosphate is the chemical which is utilized. Then disodium phosphates are being utilized. Trisodium phosphates are also being utilized. What are the coagulants? Coagulants, these are the some conditioning chemicals that precipitated the particles, means combined with that and make them precipitate and can adhere to the heating surfaces and form the soft scale part of it. Coagulants causes the fine particles of the sludge floating in the water to collect about them, means they combine, they collect it, and the larger particles thus formed, and they are less likely to adhere to the heating surfaces, and they are going to be remain suspended in the boiler water, which will be blown down through the scum blow down or the bottom blow down part, and then it is going to be removed. Oxygen scavengers, as we know that the hydrogen is one of that. These are added to remove any traces of oxygen in the boiler water. The dissolved oxygen is being removed, and the two chemicals mainly used for this purpose is your sodium sulphide and hydrogen. This is going to remove the dissolved oxygen, and this oxygen basically is main cause of the corrosion part. Okay. For the feed water maintenance, you can see daily we have to analyze the feed water and the boiler water. In case of tankers, I told you it is very much required, because if you miss one day, the results can go haywire. The chemicals control will not be there, so you have to do it on daily basis. But on the dry fleet, a weekly basis. Weekly skimming surface blowdowns according to analyze, but at least once per week, 2 minutes with full valve open. This is the direction. Blowdown, bottom blowdown. So there are two types of blowdown: surface blowdown and the bottom blowdown. So bottom blowdown according to analyze, but at least once per week. Each blowdown valve 1 minute low load condition. Check the functions of salinity and oil detection system. We have to check it monthly. Every 6 months, the boiler water side must be carefully inspected at least twice a year. Okay, water side, interior side. Yearly, check the water side of the boiler, hot well condition, deaerators for corrosion and scaling. Check the chemical pump units also. Okay, so this is some of the accessories which needs to be maintained. Some recommended guidelines for the boiler water treatment are the values which you can see. pH is 10 to 11, total alkalinity 200 to 700, phosphates 30 to 100, total hardness 0 to 50, chlorides 60 to 200, total dissolved solid 2000 ppm, maximum sulphites 20 to 30, specific conductance 700, less than 700 microohms, conductivity basically, and oxygen is less than 0.007 mg per liter. We have all the comments which is you can see. Okay, so this is basically the recommended guidelines or the recommended values which boiler water needs to be maintained. Now thank you all of you. I hope all of you have understood the boiler water treatment, why it is necessary, what are the advantages of it, what are the chemicals utilized, how the tests are being performed. Everything is being discussed. So in next coming video we will have the explanations of your boiler water type and the smoke type. These explanations will be there. So in coming soon, I'm going to put the video on that. Thank you.